So now we'll discuss about the troubleshooting methods of the Profibus network. How we can troubleshoot any problem like communication problem, communication breakdown with the Profibus network. So at first the monitoring in the diagnostic repeater from Siemens, which will be this. This is the diagnostic repeater. We'll discuss about it in upcoming slides. Monitoring with the TH-link Profibus from softening. Okay, and troubleshooting with the Profibus tester 5 from softening. This is the TH-link Profibus from softening, and this is the Profibus tester 5 from softening. So monitoring with the diagnostic repeater from Siemens. From by this types of module we can diagnostic during normal operation condition, where we can check topology, wire break, short circuit in signal lines, missing bus, terminating registers, determining fault location, all while performing standard repeater function. So topological view of the diagnostic repeater is like that. You will have to open the step 7 and select DP master system whose data you want to read. Start the function by the choosing the menu, command view, then display and then all station, only diagnostic repeater with stations, all diagnostic repeaters only. Now you can see the diagnostic repeater view. You can directly check from here. Okay, there is a CPU connected with these DP3, DP1, DP2, wherever it's connected, and what is the cable distance can directly monitor from here. Topology table of the diagnostic repeater. The topology table we can open by the clicking on view and then topology table. You can see the here the distance of the diagnostic repeater and what is the topological determination of the system and what is the cable length distance of the module will be connected here, and the segment DP1, DP2, which segment it's connected, we can directly check from topological table, and you can print it also and export it also, and addresses can be noted in here. So diagnostic buffer, this is the main advantage of the diagnostic repeater. You will get the dedicated diagnostic buffer menu where you can check the what kind of problem or what kind of situation is going in your communication line, that the communication line is breaking. Here you can see break on signal A and or B or terminator is missing. Here you can see the 40 meter and 10.2 meter where the braking condition have been occurred has been defined. Break on signal A and B, time reflection error is 100%. Check the Profibus cable and the remedy also we have been here. Okay, here is the statistics buffer of the diagnostic repeater. What kind of proper diagnostic buffer have been come, you can directly monitor from here. Start the function, the choosing option, then statistics. Here you can see the error rate of the particular communication line is for monitor when it's occur. It's also in monitoring, continuous monitoring in the diagnostics statistics buffer. So here is the error message of the diagnostic repeater. The tab DP1, DP2, DP3 and PG each contains the diagnostic for information for the corresponding segment. An icon indicates whether the segment is faulty or noted whether it is deactivated. Here you can see that this is the faulty or deactivated. Okay, DPP slave. Three output field contains graphic and text information on the fault location, type of fault, remedy, and if appropriate information on the reflection fault rate. The details command button leads to the further information, the fault cause and remedy. You can see the remedy and error is present here. DP2 is not communicating, there have error status. The CPU is run mode because of there of OV82 has been connected, the IO missing error. Okay, so you can close and then after troubleshooting the communication cable, you can directly update it here, then the communication can be shown in stable here. Okay, so monitoring in the TH link Profibus from Sopnic. Comprehensive testing of Profibus DP segment. What kind of solution you can get from it? Stationary diagnostics tool for continuous monitoring, logs and analysis Profibus traffics and network error, event and timestamp and stored in non-volatile memory. Multiple TH links may be deployed, one per segment. Information accessed via the web browser. Alarm via the email and OPC into HMI and SCADA with the optional TH scope software. If you need the operational video of this module, we'll dedicatedly provide a link in the description below. Okay. So this is the most commonly used industrial thing to rectify or diagnosis the Profibus network. This is a Profibus tester by which we can check the signal test, cable test, storage oscilloscope, protocol analyzer, frame recorder, train recorder, master simulation, Profibus PA testing, and with optional adapter and topology. So how we will use this system will we'll see in the next video. So here is the video.
You must create another network for the area behind the repeater and repeat all the steps described for this network. For the actual troubleshooting, you create 3 measuring locations. Click on test locations, enter names for the science, for them beginning, center, and end. Click OK. At this point I note the actual measuring locations do not need to be exactly at the beginning and or in the middle, but only approximately. Plug the meter into one of the measuring locations. Select the Signal Quality tab and select your measuring location. Start the measurement. The measurement should run until the red arrow below the green bars has turned to 5 to 10 rounds. Stop the measurement. Now plug the meter over and select your next measuring location. Start the measurement. Again, measurement. Take 5 to 10 turns of the red arrow. Now plug the meter to that location and proceed as before. After you have stopped the third measurement, select Cast and Save Network Status to save the measured values. Now the measurements have to be evaluated. 3 measurements are current. The rating is based on the average level. Average value is also displayed as a number. A principle applies. The worse the measurement result, the closer the measurement location is to the cause of the error. If the worst of the 3 measurement locations is determined, it does not mean that the error is exactly there to but at least it is close to it. Now the cause of the error is further circled. To do this, create 2 more measuring locations. For worst and after worst. Now measure the levels at the 2 new measuring locations. Again, compare the 3 readings. Again, the cause of the error is close to the worst reading. Now proceed according to this scheme until you have found the worst overall location. There is the cause. In our case, the termination at the beginning is missing. This happens, for example, if the shifter on the bus connector is set to on. but the internal switch did not engage correctly. Correct the error. Measure again at least 2 measuring locations. To do this, create 2 new locations. Start fixed and then end fixed. Now the values are much better. When the last measurement is stopped, select Test and save network status to save the measured value. Now you can do the report. To do this, select Test and create report. The mask that appears, enter the data of the customer, the data of the person measuring, and if desired, a free text. For example, because of the problem. Press continue, then the report will be created. Save the report in PDF format. Close the report preview. Close the report's settings window. Move the mouse over projects. Select your test report and open it with a double click. In addition to the cover sheet, the report now contains all the relevant technical data, such as bitrate, cycle time, and physical values. And this is also we have dealt with the reason missing bus termination. In principle, however, it does not matter what the cause of the error is. The procedure with the 3 measuring locations in comparison stays the same. You must.
So thank you everyone, have a nice day. If you like this video you watched, please give a like and please subscribe to encourage our efforts and all, and also have a great day from AN Automation team. Thank you everyone, have a nice day.